So good morning to all, Nana. So it's give me an immense pleasure. Welcome to the introduction of the speaker from the today, Mr. Sumanth Reddy. I welcome to Sumanth Reddy on behalf of Principal Sir, Sanskrithi School of Engineering and Chairman of HJ Group of Institution for the webinar which parts of the enhancing the knowledge of the students and the faculty towards current trends in the world. Okay, na? So today we are discussing the introduction of Sumanth Reddy sir. He is a graduate in mechanical engineering from VTU Belgium. He did his MS degree in mechanical engineering in Vienna State University, Michigan, and United States of America, with a specialization of the controls. Okay. So Sumanth Reddy is a responsibility for the development and implementation of the control system for a active value performance exhaust technology and exhaust gas recirculation technology at Ford. Okay, so this includes hybrid vehicles, plug-in hybrids, mild hybrids, and conventional gasoline engines. As a controls and software engineer of power strain and calibration of NVH North America, Mr. Sumanth Reddy is a responsibility for connected vehicle technology data that helps of understand customer usages in Ford vehicles to optimize power strains and OBD and drivability and NVH development global from 2014 to till date. Okay, so this prior to joining Ford Motor Company, Mr. Sumanth Reddy is working from sorry, working from Robert Bask Indian Research Development Center, Capital Area, UK. Okay, Mr. Sumanth Reddy holds 47 plus patents and patents applications in the area of powertrains, controls and diagnostics. Published of 5 technical papers and conducted 80 reviews for the Journals of Conference. He is also associate editor for a SAE International Journal of Engines, International of Journal of the Engine Research, an organization of the member of Powertrain Actuators and Sensor of the Session, and active members of SAE and OBD conductors. So, thank you, Suman sir. So, over to the Suman sir.
All right. Thank you, sir. I didn't get your name, sir.
Nagarjun Reddy, sir.
Nagarjun Reddy, sir. Thank you so much. So, thanks for the very kind introduction. Everybody can see my screen here?
Yes, sir.
Yes, sir.
Okay, before I start up my intro and the topic today, I just want to thank Raja Reddy, sir. I've known him for probably uh, 15, more than 16, 17 years, right? From my engineering days. Raja Reddy, sir, is my, he used to be my teacher at when I did my bachelor's back in Bangalore. A great teacher. And as a student, I mean, he used to help me a lot in terms of getting books, helping, and very curious about a particular subject. If I'm really, even today, I think about operation research that he took, and the kind of interest that he made me, and made me curious about what that subject is about and how that is going to impact, and if I read more, where will that lead me into. So even today, I can't forget those valuable inputs, sir, Raja Reddy, sir. And thanks today for this opportunity. Now, let me go ahead and start sharing my slides here. Do we have team from mechanical and electronics, or just mechanical here, sir?
Only mechanical, sir.
Only mechanical. Okay.
Sir,
Right.
mechanical and electrical, sir. Electrical students also come now.
Very good. So I hope all my brothers and sisters are will have some questions for me at the end of the meeting. So that all I'm trying to do today is share my 16 or 17 years of automotive experience in the area of automotive electronics and engines, what is coming in the future. Um, if people are really fancy and their area of, if they really want to work in automotive area, I can share from my experience what is going on in the current uh, scenario in United States and rest of the world. Where are we heading to, and a little bit of what is happening in India too. Um, hope I make it more interesting, not boring for 1 hour. So Andaru Telugu vallena, everybody, most of them know Telugu. I guess so.
Yes, sir. Telugu, sir.
Very good. All right. So good morning in India. For me, it's 1:45 in the early morning in US time. Okay, so I think brother helped me introduce myself. So I currently work at Ford Motor Company, a US United States employee, full-time employee. My research area is in powertrain controls research, basically automotive engines. I work on hybrid electric vehicles, future battery electric vehicles, and also connected vehicles. I did my bachelor's back in India. I finished my bachelor's in 2006. I worked in India at Robert Bosch, India, for like 2 years, 3 years, and then I moved to another company called Caterpillar. I worked in England for some time. I came back to India and I wanted to study further. And then I pursued my master's. And I pursued my master's here at Wayne State in Michigan, which is an automotive hub. And after that, I've been working at Ford Research and Development. If anybody is interested to know what I've done so far, there's a Google Scholar profile wherein it takes you to the what journals, what patents I have. If anybody wants to write or publish some papers, they can get in touch with me. I can share my experiences with whatever research journal publications I've done so far. Okay. Am I too fast, or are we all good?
Good.
Good, thank you. Okay, so I think this was already spoken about, but let me go through what is my day job here. I mean, I'm from automotive engineering background. I'm from mechanical. I have a bachelor degree in mechanical engineering, and I did my master's in specialization in mechanical engineering, with specialization in automotive controls, which means to say you more of software development. You know how you have engine knowledge. You have if you know a little bit of coding knowledge, both you combine both and you come up with your own control software development, because this is where mechanical, if you ask a mechanical guy, he knows more about machines. If you could ask about an electronics guy, he knows more about electronics. But the thing is, if you take anything in today's world, right, any electronics for that matter, it's all software based. Even on a lathe, for instance, a CNC lathe, it's all programmed. So electronics is embedded in everything. So even in automotive world, electronics integrated with the mechanical world is where we've been heading to. And if you have a good core skill and have some interest in learning some coding or understanding the algorithm, and you also know mechanical, then you could be a very good opportunity. People will come looking after you for jobs. I mean, they would offer you good jobs, especially in the control engineering area. So I was talking about my background. So at Ford Motor Company, I work in a research area. I mean to say, let's say 23 or 24 model year, 25 in 2025. Ford trucks or Ford performance cars, Mustangs, or super performance vehicles, right? So in the engine particular, I'm responsible for exhaust gas recirculation technology. That's a technology where you take some exhaust and put it back into the engine. So basically, when you do that, you get some fuel economy savings. So, and the way you do it is by using a lot of sensors and actuators, understanding what is coming out of the analog and what is coming out of the digital signal processing. And I know a lot of our electrical students will know about what is signal processing, what is low pass filter, what is high pass filter. So it has to do with, so my job has to do with a lot of sensor processing data and coming up with smart algorithms that can process the engine data and make the engine run at its best fuel operating point so that we get good fuel economy. So that is the EGR background I have so far. And also an NVH. When you talk about NVH as noise, vibration, and harness, in everybody knows hybrid vehicles they make much less noise than the regular IC engines, right? Internal combustion engines, because engines are a source of big noise. Any car will have to follow just like emissions standards, BS3, BS4, even NVH noise also has standards all over the world. In North America, you have different tests that you need to pass in order to sell your vehicle. In Europe, you have a different standard. And the rest of the world also, we have a different standard. India takes a part of it from Europe. Although I would say it's mostly based off an European legal noise requirement that we use in India to certify our new vehicles. So that is a little bit of background on what NVH means and what we do in here. Before we sell our vehicle, we need to certify that our vehicle noise is within a certain limit. Okay. A little bit of my publications, what I do. So I would recommend any student, I mean, if you have an opportunity and you're interested, go ahead and publish something, write something new. That will definitely help you to get a strong hold on the subject and also be an expert in that particular field. A little bit of my background. I hold probably 50 patents, of which 10 are granted by United States, and of them 2 or 3 are licensed to big companies and Volkswagen and other companies in Europe. The whole point that I'm trying to make here is, if you have an idea and you have something new, or if you don't have an idea also, you have a method. Let's say you're designing a small mechatronics chip that can automatically light a room. So if you can do it differently, you can think differently, that'll really help you, because that is helping me progress in my way of thinking. Every day I go to job, I would like to do something new. I guess all budding engineers I see here would like to do something new in their life, right? So make life more challenging. So take a problem, understand the problem, and see how you can contribute to the problem by coming up with a good solution. In fact, if you're all a good engineer needs is understand a problem, simple problem, how to diagnose a problem, and how he can come up with a different solution that can serve the purpose. That is coming from my experience of my 15 years of auto industry experience. Again, so I'll give my contact details later after this presentation. I'm an associate editor for two journals. One is SAE International Journal of Engines. That's a very good journal especially in the engine background in the automotive world. And there is another journal called International Journal of Engine Research. I was talking to A.K. Agarwal, if you have heard of him. He's from IIT Kharagpur. So he has published a lot of papers, especially in the engine research area. And he was talking about how India is progressing towards hybrid electric vehicles, how a lot of investment is happening in India in the hybrid area, and how the Indian automotive industry will look forward, looking for all new budding engineers, especially with some battery knowledge, with some engine knowledge. Yeah, so that's a little bit of journal and publishing. I'm also part of the SAE OBD. OBD is onboard diagnostics. Everybody knows, right? Anybody who owns a car, if there is a problem in the car, a warning sign shows up in the front dashboard, right? So that warning is an indicator. It's telling the customer that, hey, something has gone wrong in the car. You have to go fix it. So it's an onboard indicator. It's telling you to diagnose some faulty components in the car. Okay, today, and I don't know how much time we got, but let me, my whole purpose here is give you a brief picture of for the next 10 years. Are all of you graduating? When are you guys graduating? Is it like, are you in third year or fourth year, or what semester are you guys in?
Final year, sir.
Final year. Okay, very good. So you guys are actively looking for internships or jobs, right?
Yes,
Should
sir.
be probably, yeah. I just want to let you know, in the first topic in the automotive software and electronics, in the next 10 years, what is the market? And a little bit of OBD is what is OBD and what is it in the vehicle that we are talking about OBD. Am I too audible? Is it too fast, or you guys are okay? Any feedback?
Okay, sir.
It's audible, sir. It's okay, sir.
All right, thank you. Are you guys interested in autonomous driving, car driving by itself? People have done some research. You guys know anything more about autonomous driving?
Tesla cars.
Tesla cars, okay. Anybody has driven Tesla car or seen Tesla car? Or, anybody can share what they know about Tesla cars? Okay. Okay. All I want to say was Tesla cars have different level of autonomous vehicles. We are not fully autonomous yet. Means to say, if a car is supposed to be called autonomous vehicle, it has to drive by itself and meet different levels, like level 1, level 2, level 3, level 4, level 5. So right now, most of our vehicles are autonomous driving, are not in that level 5 area. They can probably drive if you select a button, and it can probably drive in one lane, just follow one lane, and it won't deviate, go left, right, just per lane following. Okay, in the next 10 years, what I can tell you is, this is all from McKinsey. Automotive market is going to increase from 238 billion to 469 billion between 2020 to 2030. So what does that mean? So this means a lot of market growth is going to happen in the software and electrical and electronics market. Okay, now we know, okay, we got some numbers, a lot of revenue going in and out of the country, and you have the overall automotive growth market happening. Now let's understand in three different, okay, you know automotive industry is growing, but what exactly is growing? And what part of the automotive industry is growing? What skills do you need in the upcoming market developments? Okay. Here is a picture. You guys can see my screen. Can you? Feel free to. I want somebody to tell me what
Yes,
are
sir,
these
please,
different
please.
symbols. One is Wi-Fi, a cloud. I can tell you. This is a satellite, right? This is GPS. Yeah.
And Wi-Fi. Camera.
Camera, right?
Location.
Location. That's very good. And you have buildings also putting some data, right?
Yes.
Okay. So the reason I'm showing this picture is right now today's our cars, right? They don't talk to the buildings. They don't communicate. Back in India, I'm telling you. So back in India, we don't have a cloud that takes some data and does something inside the car, right? Car now responds to whatever it has on the sensors, and it just it drives by whatever the customer inputs, right? But what is coming in the next 10 years? So you will have a cloud-based vehicle monitoring, like you will have a remote monitoring of how your car is performing. They might send you some software over there and flash it inside the cars so that the car performs better than it performed yesterday. So in terms of fuel economy and all that. And what will happen in connected vehicles is, and Internet of Things is, you have, let's say you have two cars, and the two cars can communicate and talk to each other and share some information. Let's say my car is going towards Bangalore, and I have another car, and another car following maybe like 30 minutes back away, and the first car which has reached Bangalore is going to tell the other car, hey, I'm on this highway. This is really this highway route is really bad, and you can take an alternate route. And that information goes to another car, and the other car, being smart, takes another alternate route and reaches its destination. In a way, it is proposing a new path for lesser fuel consumption. So that's how things are changing, wherein cars tries to communicate its sensors and driving experience from one car to another over the cloud. So when you think of this, right, what all is happening in the background is a lot of stuff. So you need a server to take this ECU data from the car, put it back to the cloud, and from the cloud, it has to go to another car. So there is a lot of data processing here. So this is just one example. And the next thing is, when we talk of autonomous vehicles, right? The autonomous vehicles have to locate themselves with reference to X position. Let's say heading towards your engineering college. So your engineering college building is not going to change, but your relative position with respect to the building was going to change. So you're localizing your position, means to say you want to know your position with respect to your fixed position. So the new autonomous vehicle software will need a lot of mapping inputs. So if somebody wants to drive a Tesla car all by himself in a particular area, that entire area has to be mapped. Just like how we are doing currently with our country is facing, right? With COVID testing. I mean, we need to understand where exactly the COVID is spreading. You need to map it and see where the case rates are high. Based off that, you take your next action. Similarly, if you want to go to a certain location, you want to understand what that certain location looks like with reference, where are you with reference to that location? And you need to understand where you are. So the big picture, all I'm trying to say is there is a lot of electronics, a lot of software, and a lot of camera processing, a lot of Internet of Things coming in the future. And the whole goal is to reduce emissions, better comfort, no driver, passenger car sharing capability, and all of this is coming. Okay, so this might be interesting for electrical and electronic students. They might, if you take a car, right, there are like 100 ECUs, more than 100 ECUs, and electronic control units. Yeah, you might be more, I would say, theoretically, you might have more knowledge than me in terms of electronics, especially the processors. And I remember just reading 2 different processors during my college days. But in here, all I'm trying to tell you is, there are thousands, hundreds of ECUs performing a specific function, right? And an ECU, a computer ECU or a computer which is there to control your engine, only controls the engine, and then tells, okay, how much torque, how much power it is producing to another person or another computer which is doing another thing. So how the complexity of electronics is so vast and complex, right? So, and with the new technology and with new requirements, with customers demanding fully automated, so you can imagine how the complexity of the electronic computers or electronic control units increases. All good so far? Am I audible? And how is the space? You guys can hear me okay, right?
Good, sir.
All right, okay.
Yes, sir.
Software and electronics 2030. Okay, well, what am I trying to tell here? If you talk about where are we today? First generation, second generation, third generation, fourth generation, fifth generation, just like iPhone, right? You've seen how iPhone has developed? iPhone 3, iPhone 4, 5, 6, 7, 8, iPhone 10. Now, similarly, with respect to architecture, a vehicle network architecture. So the way we are today is we have independent ECUs. And what ECUs are is, just I told you, they're computers, right, which control a specific function of a computer, of a car. And it has a specific function. It does whatever it is supposed to do. Then we had a second generation of a software, a kind of a network architecture, where you have different computers within one domain. And you had, okay, let's say there are 6 computers, and then 3 in 1, 3 in 1. So that 3 computers used to do their functions. They talk to each other, and that's how they were processing between 1 to body, powertrain, and chassis. Powertrain 3 computers, the chassis 3, and body 1. Then what happened? We had a central gateway. Okay, what central gateway is? Okay, all these computers go to the central place, and then they share this information over CAN. Now, what is happening in the next generation, 4th and 5th? All this, you see the complexity of number of computers, that is gradually reducing. And the number, all you need is a sensor and an actuator, and you have a central gateway. So why are we doing this? So, I mean, the lesser the number of architecture in terms of centralizing, in terms of how every computer has to do, and in terms of processing the algorithms and all that, right? If you have one computer that can handle 1,000 functions and common functions, and then you save a lot of computer memory and processing time and power and all the heating part, thermal efficiency and all that, right? So this is where we are heading. So we'll have less ECUs, less computers on the vehicle with high sensor processing and actuating capabilities in the next generation and the next 10 years. Okay, so I think this is the essence of what we wanted to tell from this particular slide. Okay, let's say we want to, in here, I want to talk more about three different vehicles. Everybody knows what ICE is, right? Internal combustion engine. It could be a diesel or a gas car. And then you have BEV, it is battery electric vehicle. PHEV is plug-in hybrid electric vehicle. All right. So 2025 is blue, 2030 is black. With IC engines, in the next 10 years, this is like within US and the rest of the world, it will still be there. Just because I'll tell you the rationale as to why the petrol and diesel cars will still be there in US. But you see the number, it is like 2,210 volumes content. But if you look at the battery electric vehicles, right, the volumes, it says 20, it is doubled. How about the same sample time for hybrid electric vehicle, which is gas and which is basically petrol and battery? You see how the volumes are increasing in the next 10 years. This is basically telling whole world in North America, China, Europe, even in India, they're investing heavily towards hybridization, electric vehicles, but we don't have the infrastructure yet. If I were you, I mean, just coming out of the college, these are the core areas where automotive industry will be looking for engineers, especially in the battery electric vehicle area, plug-in hybrid electric vehicle area. And industry will be looking for engineers who can write some software, who have some ECU, DCU knowledge, who knows what different kinds of sensors goes in a vehicle, and also different kinds of power electronics and battery. Battery is a big plus point. So if I were you, I would probably get well versed with these areas of the vehicles and the components, because this would help you prepare for the next technology jobs. Yeah, I mean, maybe I can share this slides later. Maybe you can see how the number of ECUs are going to be. You can see from 2020 to number of 2030, the number of computers are too low. Why? Because you have a smart computer that can handle. You were using 10 computers, but now you're using five or six that can manage and perform the same as 10 computers. That's how the hardware capability of ECU control units is. And then the software. Once you have the hardware doing that smart thing, then the amount of capability of the software would also reduce. But you need a very good sensing and actuator knowledge in order to perform that. Okay, this is also again component wise. Okay, if I were to look into a vehicle, where exactly the market is going, industries are investing heavily in software, 10%, how they invalidate their software. Probably if I take 100 rupees, right, and if I were to own an automotive industry, and if I want to develop a new car for the next model year, 10 years down the lane, then I invest my money to develop the technology wherein I can improve my software, develop my software very fast. It should not be like 1 year to develop the software. It should be like 1 month. The faster you develop, the better the product, and not better the product, but at least you're ahead in the competition with others. And the ECUs, they're trying to invest to make sure they have a better quality and a more processing capability ECU in terms of memory time, processing time. They're looking at sensors, analog, digital, sensors. They're looking at some smart electronic components too. this is basically a big picture of what goes inside the vehicle, and in the next 10 years, how a company is majorly investing and focusing its time and energy on. Okay, we still are running based on petrol and diesel engines, right? And what if somebody is going to ask you, what is the future of IC engines? Well, it is dependent on many factors, because we have been living with IC engines for last 100 years, I guess, from 1920, almost, yeah. You remember the first Ford vehicle, Ford T, was in 1910 or 1916, I guess. Yeah, that's when our first Ford vehicle was. That's when we had 4 wheels on the road, which was propelled by petrol. Because and the future of IC engines is also dependent on and how fast we can replace the massive infrastructure. In India, you go every 1 kilometer or 2 kilometer, you have one petrol station, right? Now let's say you don't have gas or diesel engines tomorrow, then what are those? Then you need to replace those gas petrol stations with battery recharging. All right. So how you can think how much government has to invest in and probably indeed coming up with those stations where customers can go recharge, or maybe outside the apartment they have to come up with a recharging port everywhere. They have to do a lot of power transmission to support that big electrification process. Well, it's a step by step. Okay, you want to, the whole industry is moving towards electrification, but the question is, can you go it in step? Instead of going all the way fully battery, can you have a vehicle which has battery and engine? Yes, so that's a hybrid electric vehicle, right? So there is a lot of research going on in that area too. But the problem is you need to have good batteries. All the OEMs are investing heavily in the battery research, and so that the more the battery range, the more the vehicle can last for long distance. The last thing is, even though companies are investing, you need government policies and regulations to come up and meet the actual plan of the company. So this is another challenge, especially in terms of in this different political environment, coming up with different policies and making sure the public is not affected at the same time. The countries are progressing towards in different technology. Okay, hope everybody is listening, and hope I'm making it interesting. Or maybe we can talk for some time. I don't know how much time I have. Okay, I think I can go on for another 20 minutes, I guess. You have another class after 20 minutes?
Sumanth, you can take the session as long as you want. Till 12:30 we have the session planned, but
okay, sir.
Whatever extent you want to extend, you can extend.
Okay, sir. Thank you. All right. Okay, let's talk a little bit about emissions. So emissions, the major pollutants are nitrogen oxides, carbon monoxides, hydrocarbons. And we have emission regulations, or the government regulating agencies controlling. If anybody wants, let's say Mahindra or Toyota or any OEM for that matter, if they have to sell the vehicle, they have to meet BS4 or BS5 emission standards, right? And when they say BS5, what does it? I mean, basically, they're saying you have to meet your NOx like 5 gram per kilometer when you are in a city and a drive cycle. They have certain standard drive cycles. They have to run it in a test scenario, wherein they'll have a test cell wherein they will simulate a similar driving condition as a customer drives it on the road, and they will measure the exhaust. They take some sample of the exhaust, dilute it, and then they try to analyze the emission constituents of the exhaust gas, and then tell how much of, if I take 10% of the exhaust flow volume, how much out of that, how much is NOx? Is it 2 grams per kilometer or 5 grams per kilometer? And what is NOx plus HC versus particulate matter? The soot or the dark carbon particles, right? Which is very high on diesel vehicles. So what is that weighing? Then they say they have to, all original equipment manufacturers have to comply and all the emissions within a particular box. I mean to say within a certain limits. And that holds good even for particulate matter. So these are some of the challenges that I was going through. What is IC engine facing? One is policy. One is the battery. Heavy focus on batteries. We don't have good long-ranging batteries, but you need let's say overnight, if you charge in US, you can drive a vehicle for like 400 miles. That's a truck. But what do you do after 400 miles? You have to again charge it. But if you had a IC engine, all you need to do was go to a gas station. But the thing is, okay, when you're finished with your 400 kilometer or 400 miles of range, what do you do next is you need to look for a nearest charging station. But in US, there is a little bit of infrastructure for that, which is slowly improving. But in our country, like India, we need infrastructure to support battery electric vehicles. So that's a challenge. So until then, the future of IC engine is still going to sustain and be there. So in our current political environment, we hear in news a lot of things about Paris Climate Agreement, right? So what is it all about? So this is all about how much India as a whole has promised to reduce the greenhouse gas emissions, and it looks like the current administration is working towards it and very well in the limits of meeting the climate agreement proposed by Paris Accord. So overall, not just as in India, we are also contributing to the overall global greenhouse gas emissions. The big picture is collectively, most of the countries are working towards reducing the greenhouse gas emissions. I think the whole goal there is to reduce the global warming phenomena. Okay, so the next, engine efficiency. Why are we talking about a future research direction? We spoke about what are the challenges. If I'm in the combustion area, if I'm in the IC internal combustion engine area and doing some research, are we getting rid of all the engines? No, I mean there is a lot of research going on in the engine area. You can think of big trucks or big vans, right? Still, you don't have a technology. You can think of 407 Tempo Traveler, right? So which is currently a diesel. And let's say tomorrow there is no engine for that. Then what do you run with it? It's a battery. But question is, can you run the vehicle with a battery? Do we have that capability? No, because you know TT runs so many miles and the infrastructure is so good for petrol's availability. But if you think of having a Tempo Traveler with just a battery, then you have to recharge it, and still that technology of large scale batteries, packing and installing and recharging is still a challenge to the industry, which if you guys are interested, maybe you can start writing, think about that area of how you can meet, how you can develop a hybrid vehicle or a battery electric vehicle for big size tempo travelers in that particular vehicle segment. So that's a very good research topic. If you guys want to invest more, that's good area to invest on. The other factors where internal combustion engines are progressing is they're looking to make sure, okay, we have a combustion system, you have injection fuel going into the engine, you have high injection pressures, what you can do further with getting still more efficient combustion. So one thing is you can do is you can use EGR and also high injection pressures. Like say in diesels, you have common rail diesel injection, right? So wherein you use a common rail to generate high pressure, and then you're injecting the exhaust, sorry, not the exhaust, the diesel spray through the injector at very high pressure with the injectors. So what that is happening is this basically assisting you to get good combustion with less particulate matter, assisting you with an exhaust that produce less pollutants. So so you work with fuel injection pressure. You have you're working with different combustion chambers. That's another thing. So it's piston bowl, the way air is flowing inside the combustion chamber, and how the piston crown can be designed. So those are some of the internal combustion design factor. If you've gone through the IC engine class, then you will know what I'm talking. This is all mostly related to design of the piston and piston rings and combustion chamber and all that. The second thing, all automotive OEMs are researching can they improve on gas exchange? When I say gas exchange, how can they improve how the engine is breathing? I mean, to say, let's say you put a turbocharger. Everybody's aware of turbocharger. So turbocharger gets you more air, more boost. And so definitely you have good fast response. And when you're doing it, can you implement a supercharger? That's another possibility. People are looking into this. And also almost 30 to 40% of the energy is wasting in the exhaust. There is so much heat in the exhaust. If you burn X amount of fuel, then only like thermal efficiency is 30% or 35 to 38%, I guess. But the rest of the energy is lost. Where is it lost? It's all going in the exhaust as heat. Well, can you tap all the heat and recover and use it for something else to do in the engine? Yes. So nowadays you're using, you can see there are technologies where people are tapping the hot exhaust gas and you're rerouting back into the engine to heat the coolant. What happens? Why do you want to heat the coolant? Coolant is basically something which would cool the engine block, right? But you will, if you have a coolant which is rising very slowly, then you will customer will spend a lot of time with a lot of fuel economy. If you have a warm engine which heats up very fast, then customer will save some gas or fuel. So this is the technology, exhaust gas heat energy recovery systems. This is a very budding technology, I could say, where people are investing so that they can tap in the exhaust heat. Electrification. So electrification is the point here I'm talking with respect to IC engine is it's a combination of engine plus hybrid batteries. So you can combine both to have a greenhouse gas target within and still achieve a thermal efficiency, good thermal efficiency. And researchers are also looking, okay, you have engine lubrication. Can you design an engine which can which does not have high mechanical losses, which means there is very less friction and still operates at high efficiency. So people are coming up with good lubrication mechanisms that can reduce the friction. Overall, engine thermal and energy management. So good after treatment systems. So you need, on one hand, you have a lot of exhaust heat recovery technology. On the other hand, in the exhaust, you have a lot of catalytic devices, diesel particulate filter. In case of petrol engines, you will see a gasoline particulate filter. A lot of these new technologies coming up. What happens if somebody goes and puts a hand in the exhaust? Will the vehicle run? No. Why? Because you're blocking the exit path of the engine. On one side you're breathing and on the other side you're blocking. So what happens if you put a lot of devices on the exhaust? You create a lot of back pressure, right? So we would not want to do that. I mean, we would want to create a system where your engine produces some power and wherein the customer experience a good performance and also produce less emissions, right? Yeah, I just spoke on engine after treatment. That's an area where I work on a day-to-day basis, especially on GPF, on gasoline particulate filter. There are requirements where when you are cold, your engine should produce very little emissions and particulate matter. A lot of research is going on in that area, especially what you can just think of it just to reduce HC and NOx, just HC and CO, right? You use the oxidation catalyst. There is a ceramic material in the exhaust, which traps in all the exhaust, and that itself design is a very complex piece. It involves a lot of knowledge, people with design background who knows the chemistry of what is in the exhaust gas and what happens when the exhaust gas goes into this filter and what is the chemical reaction. So you need to know what is the different, a good chemical engineering background and a good mechanical background to analyze, okay, now my HC is going high. Now let me not burn the fuel very rich. Let me burn lean. You know what lean or rich is? It's basically high, you're trying to calculate or control the amount of fuel, whether you want to burn lean or burn rich, so that your emissions go down, up and up. So that's another area where a lot of interesting things are happening, especially to meet emissions, fuels. So what happens? I mean, you can have a number of things, but what is the source of energy? It's the fuels, right? For an I see internal combustion engines. A lot of research is happening here too. So dual fuel combustion, there is a natural gas. People are talking about natural gas. A direct fuel injection is picking up. Basically, low octane number fuels will become important, especially in the near future. If you need system supporting. On one hand, you know there's a lot of fuel activity happening, but also you need to have additives. Also, you need to make sure there is an adequate infrastructure to support your fuels that can help you with the combustion matter. Okay, so I told all these engine parameters, but the takeaway is at the end of 1 hour, you've been listening to me. I just want to let you know that IC engine is going to still be there. And if somebody is looking to do some research in the engine development, there's a lot of scope in the area of engine simulations and engine vehicle control. Okay. So this is more of onboard diagnostics. In America, you have this regulation, just like in India, we have Bharat stage 4 or 5. You need you have California Code of Regulations just to sell vehicles in California, and outside California, you have to meet EPA emission limits, Environmental Protection Agency regulations. Any vehicle we sell here has to make sure your systems are working. If the system is not working, let's say you have a throttle sensor. If that sensor fails, you need this, the regulation says, the law says you have to, the vehicle software should report a warning on the dashboard, a mill light indicator, a GST. But this has been there for last 20, 30 years. But what is happening is the more number of emission components in the vehicle now, just to meet after treatment, there is a lot of exhaust components, right? So a lot of things are monitored when you drive the vehicle. So when you have 5 sensors, that was a different story. But now when you have 20 sensors and 20 controlling actuators, so then the company can understand the complexity of the system, right? So then you need to develop a good monitor, or when I say monitor, is a good checking tool which keeps looking at each and every component and sees whether it is behaving properly as it is required or no. So such is the requirement that we see in the future. Okay. Battery electric vehicles, still the regulations are in that there is no regulation so far in US, but it's coming. It's coming probably in a couple of years down the lane. Okay, so all right, I think that was my colleague's slide, so that's why I don't know if you were hearing something, but let me go to the slide. Okay, in here, the thing that I want to tell you is, well, you know what goes in a battery electric vehicle, plug-in hybrid electric vehicle. There are different systems inside the vehicles: a battery, motor, heat management, braking. Why braking is important? Because when you brake also, you generate some good, you recover some energy that can recharge the battery. It can regenerate the battery. Regenerate the battery. And an inverter and a converter. A drive system is basically the transmission. On a plug-in hybrid electric vehicle, you have both the big yellow thing. On a BEV, you have this particular integrated thing. All I'm telling here is, if you look at a battery electric vehicle and PHEV, these are some of the systems that are going to come, and people who are going to be in automotive OEMs, they're going to be working on one of these systems, because the next 10, 20 years, they'll be working on one of the system. If they're in the controls area or manufacturing area, they could be manufacturing one part, or if they're in controls area, they might be writing some software. If there is an electrical engineer here, he might be developing a new sensor for engine that can transmit the data faster. And if he's if somebody's in a mechanical background, he would also be, if he is a regulation engineer, he will go run some tests, make sure he meets the laws, Indian laws of emissions. So, but you might deal with one of the listed components here, maybe 10 years down the lane, or whenever you work in any automotive industry, you might come across some of the components here. And also a lot of research is going on in the motor, battery to be making more efficient, and how you can reduce the battery heat, especially in the thermal management area. They're coming up, people are investing heavily in creating a smart transmission and coming up with an engine that can coexist with the battery. That's a PHEV. which can give good fuel economy. I guess I'm 1 hour on time, I guess. Yep. All right. I'm ready to, hope I didn't make you guys sleep. Are you guys awake?
Sure.
Yeah, I mean, guys have some questions for me? Feel free. I mean, free matladochu. No issues for me. I mean, it's more like you want to know
Sir,
something.
can you elaborate on modification of transmission system for electric vehicles?
Elaborate on what? That was a good question. Can you say that again? Elaborate on?
Elaborate on modification transmission system for electric vehicles, sir.
Okay, so let me see. I had this paper I was reading this morning. I can tell you it's a dual mode transmission that people are working flare. So if somebody is designing the transmission, right? So they would be designing to make sure the dedicated hybrid transmission is it is optimally serving the electric machines. You have different dual hybrid transmission modes: E mode, S mode, and P mode. E mode is electric mode, sport mode, and parking. So in each of these modes, your drivetrain, your shift, your shifting should be smoother. When a transmission, when somebody shifts up, it's more automatic, right, in this part of the world. So when they use this and they shift from one state to another, the shifting should be proper so that the engine operates in a fuel economy area, like 3000 RPM, 50 Newton meter torque. That's a good operating point for an engine to save some fuel. But what if your transmission is in higher gear and it's operating at 6000 RPM and 30 or 40 Newton meter torque? Then you might, your transmission, then because of your transmission, you consume a lot of fuel, right? So efficient shifting is needed from the transmission. So if you have a good transmission that can shift gears at an efficient operating engine area, that'll be helpful.
Thank you, sir.
Sir, can I have a question?
Yeah, feel free. Yep.
About come to the point of speed, sir. In India, almost highways use a lot of speeds like 120 km/h. Everyone used to like to drive a car in 120 km/h in Indian highways or above 90. Where comes to electrical car? Electricity is more than speed of speed. How can we overcome this speed management and speed regulations in this electrical car?
How can you overcome what?
Speed, sir. Speed. How can we even if we you said, no, sir, in overnight charged and it comes to up to 3,300 miles.
Yeah, 400 miles.
Like
yes.
that, how can we okay, 400 miles. How can we possible to have a lot of speed with the same 400 miles?
Yeah, when company says you can run the vehicle with no issues for 400 miles, which means it is not compromising on speed. Even if you have 1 mile left for the battery is getting over, you can only run only 1 kilometer. Even that after covering 399 kilometer, your performance of the vehicle will still be the same. Means to say, you can hit 0 to 60 kilometer per hour in 4.4 seconds. So your performance won't deteriorate. Your battery transmission performance won't deteriorate. That's the way they design it. Your engine speed will not change just because your battery has lost its state of charge.
Hello.
Yeah.
Is there any particular reason why the wheel drives are driven by the motors, not by the IC engines in a hybrid engines? Hello.
Yeah, sir. So the I think it's a dual, depending on the battery state of charge. If the battery state of charge is less than some 20 or 30%, then the control software will tell, let's go run the engine. But if it's the battery has good state of charge, then it will definitely run based off motor. And the reason why they would want to run on motor, because even if you have if you are braking, you can recover some energy and you can recuperate and recharge your motor while we are driving.
Sir.
Yep. Hi, Karthik.
Sir, what are the possibilities that IC engine will be phased out from manufacturing?
Phased out from manufacturing, that's a lot of...
As we see, sir, in India, advancement in electrical vehicles is increasing day by day. Does this affect the manufacturing of IC engines?
Manufacturing will not impact until 2050, another 20 years at least, and depending on how India invests in hybrid. You can assume this, the manufacturing will be impacted once you start seeing petrol stations replacing with recharging stations.
Yes, sir. Yes, sir.
So if we are at that point, then if you see everywhere the recharging stations, then you can think maybe 5 or 10 years after the recharging stations are there, then that is the end of IC engines.
Okay, sir. Thank you, sir.
Again, lot of things come into picture. You can just take it as a thumb rule. When an economy or a country is in a state where the technology is for battery electric vehicles, you have a lot of charging stations, then it's progressing towards complete hybridization.
Thank you, sir.
Welcome, Karthik. Yeah. Good questions. A lot of people, looks like they like cars.
Especially me, sir.
Good. Yeah. I mean, if you're passionate about cars, yes, definitely. What have you guys thought about doing in future? I mean, obviously everybody will have something in mind, right? How many of you want to be in automotive industry? So most of them are muted.
Hello.
Yes, sir. Yeah.
Any more questions?
I think Pranav has some question.
Okay, if no questions, we'll wind up this session with the vote of thanks. Any more questions, please?
No, sir.
Okay. So it's good afternoon for us, and I hope it is early morning for you.
Yes, sir. Ikkada 3 a.m. in the morning. Yep.
Yeah.
To 10 minutes back. Yeah.
I'm extremely sorry for extending the hours.
No, sir. I mean, any time for my for my country and for my students. Yeah.
So thank you for giving the section for us. So give me the feedback links for you, sir.
Yeah, I'll definitely share the links. Good afternoon, ladies and gentlemen. It's very good interaction with you all. It gives me an immense pleasure to deliver the vote of thanks for this event to all the dignitaries assembled here. I would like to thank our chief guest, honored with function with his inspirational thoughts. I would like to thank our beloved principals, staff members, students, participants, volunteers. Last but not the least, our beloved audience for making this function a grand success. And once again, I thank one and all present here. Thank you. And thank you, Sumanth.
Thank you, sir. Anytime. Thanks for the opportunity for me
Sir,
sharing.
I want to give a vote of
Go ahead. Yeah.
Go ahead.
Suman sir. Thank you, sir. Thank you for taking time from your busy schedule and briefing us about the advancement and future technologies which will be evolving in automotive and hybrid vehicles, sir. Thank you, sir.
Thanks,
Thank
sir.
you for taking time from your busy schedule and conducting this webinar, sir.
Yeah, sure. Anytime. So any questions, you can always check with me. I'll have my email ID out there. All the best for you in the next, I don't know how many months more we are graduating. How is the job market out there? It's pretty good. Getting calls?
Not so gloomy.
Not so gloomy. Okay. Yeah.
Yeah.
I wish you all a very good job search and very good luck in the future job search and careers. And stay safe. I know it's tough in COVID. I've lost a lot of my friends and some in and outside the family. It's a tough time for us, but as long as we take all the precautions, we should be able to defeat it. Just this COVID. And pass through this tough time. I know it's hard to learn online also. As long as you have your interest and motivation and you want to do something in life, I guess everything will fall in place for you. Good luck, everyone.
Thank you, sir.
All right, sir.
Anything you want to say, Sumanth?
I'm good, sir. I'm good. Yeah. I'll keep in touch. Is there if you guys want to know anything in specific, maybe I don't know, just send me an email. Maybe I can share that information for you. And I would say recommend, if you get a chance, go write some papers. SAE in India, I don't know. But if you write some papers, if you submit it in SAE US, I am part of the committees. I can get you, I can give you some feedback, and so that if you have a paper published outside, then it will give you wider recognition.
Thank you, sir.
Yeah, thanks all. That's all, sir. Thank you.
Yeah. Good night, Sumanth.
Thank you, sir. Have a good day, everyone. Stay safe. Bye.
Good night, sir. Nice presentation.
Yeah, bye.